For more updates, click on subscribe and click on bell button for latest notifications. Hi friends, welcome to Tech Arkit YouTube channel. My name is Ravi. In this video session, we are going to see that AWS Compute, which is a core AWS service EC2 Elastic Compute. So AWS Compute EC2 Elastic Compute Cloud, this is an EC2 Amazon Elastic Compute Cloud EC2 is a web service provided by Amazon Web Services. So that is an AWS that enables users to launch and manage virtual machines, so which is called as an instances on the AWS cloud. So you can launch the virtual machines using this EC2 service, right? In EC2, actually it provides a scalable, flexible infrastructure for running applications, just like you can scale up, scale down based on the requirement. That is called an Elastic Compute Cloud. So infrastructures which can run applications, hosting websites, and storing data, among other use cases, right? You can use this EC2 instance as just a virtual machine. You can use any purpose, right? So where you have a region, this is a first region. You have region in the sense geolocation, where actually geographical location is set, something like India, Mumbai is in a region. So where you have so many availability zones, right? Availability zones in the sense those are the combination of multiple data center, which is called as an availability zone. You will have, so this is just like one region. You can select a resource on that particular region, right? So that any region which you can select based on your requirement and use cases, right? So this is a simple region setup, how it looks like. So how you can access this EC2 instance? So basically you can access using the AWS Management Console, right? You can just go to log into your AWS console, and from there you can access your EC2 instance, and you can use shell, which is a secure shell, SSH access, just like you can use any of the tools like PuTTY or any other remote ng or any other tool. You can use the protocol SSH. You can log into the EC2 instance. So if it is a Linux machine, you have to use the SSH. If it is on a Windows machine, you go to the remote desktop protocol, which is an RDP. So you have to use the RDP protocol if it is on a Windows machine. So you have to using that. EC2 instance connect, so EIC. So this is a console access, where you can access any instance which is a Linux or Windows, anything. From AWS Systems Manager also you can access the EC2 instance. Let's say on-demand pricing model. So how the on-demand pricing is done. So this is the most flexible pricing option, allowing users to pay for compute capacity by the hour or second without any upfront fees or long-term commitments. On-demand instances are recommended for shorter or unpredictable workload that cannot be interrupted. So this means that you can no need to pay. Example, say that you don't need to buy a server, you know, to buy a network gear or anything such as sort. Here you just have to spin up an instance. Then how much you utilize that instance, that much you have to pay. So it's just like you utilize how much you are utilizing, pay for that. So that's the on-demand pricing. But this is recommended for short terms only, because if you utilize similar way in an on-demand process, right, you don't get a much savings on that. So this is just like to have the unpredictable workloads, means the workloads might grow up or come down. So that's something like you don't have an idea how many users are utilizing, how much traffic you're getting, how much CPU load, or how much processing is getting utilized, all this stuff. You don't have any idea in first place. Just run an EC2 instance and gather some statistics. Based on that, you can set up a workloads which is predictable workloads based on your requirements. That is a later part, but to start with, you can have the on-demand pricing, so which you can do just like go ahead and bring an instance and utilize, and what you utilize, pay for it. Use cases. So basically you care about the low cost without any upfront payment or long-term commitment. So that is the main use case here. Applications that are unpredictable workloads and not be interrupted. So it is not for an uninterrupted services. You can use this on-demand pricing. Under development applications, so which is the applications which are under development, which is not yet to be production. So that is a best use case for this on-demand paying price model. Workloads that are not run longer than an year. So maybe you run some applications on a seasonal basis, right? Then you stop those for after once the season is completed, something like that. So that would be use case for this on-demand pricing. So another pricing model is reserved instances. This pricing option provides users with a significant discount up to 75%. Okay, so that is a big saving you have compared to on-demand pricing in exchange for committing to use instance for a 1 or 3 years term. So the savings comes because you have to commit since that. So this is a predictable load where you have the applications use this much CPU, this much RAM, and this much processing compute. So you have some predicted loads. Then you can say that take the sizing, instance sizing, and reserve that for 3 years. So commitment. So that way, what you have, that you will have the savings, more savings on that utilization. So reserved instances are recommended for stable workloads that are running 24/7 or have predictable usage patterns. So where you can use these reserved instances use cases, your application has steady state usage and you can commit to 1 or 3 years for that same steady usage you required for an upcoming 1 to 3 years. Pay money upfront to save or get discount. So you have to pay some amount to get commit for 3 years. Your application requires a capacity reservation. So your application requires a capacity reservation, means this much capacity I need for these applications to run. So sizing has to be done when you are running your application. You require sign a contract with AWS. So you have to sign the contract to reserve your whatever the instance you choose for 1 or 3 years. You have to sign the contract. Capacity is reserved for you in a availability zone, so where you select this your region and availability zone. So there is a spot instances. This is a pricing model is available. This pricing option allows users to bid on unused EC2 instances capacity. So there are some unused EC2 instances, so you can bid for that, just like you put in some bid on it, with prices varying depending on supply and demand. So if you have any more demand, you may get bid goes up. If there is no demand for them, so the price might go low. Okay, so here spot instances can be up to 90% cheaper than on-demand pricing, right? Because those instances are not utilized by anybody else, they are kept free, so they will put some bidding on it, but can be interrupted if the spot price exceeds the user's bid. So example, say that you have put something $1,000 to utilize, so you choose a spot instance, right? So if your budget, the $1,000 is completed, then the spot instance may go off. So you cannot rely on these spot instances, but this is only when you need a capacity, the interrupted workloads, or just a batch processing workload, something like that. So you can use this spot instances. If the capacity is needed by on-demand or RI users, right, spot instances are recommended for fault tolerant, flexible, or batch processing workloads. So where you can use this model, basically what is the recommendations? You are not concerned about the start or stop timing of your applications, because this might be interrupted when your budget is completed, right? The budget is completed, it might be interrupted. So you don't worry about the start and stop of your applications. So that's where you have to use this spot instances. Your workload can be interrupted. So your workload can be interrupted anytime. Okay, save up to 90% on-demand processing. So this is more savings when you choose the spot instances. Pay the spot pricing that's in effect at the beginning of each hour. Okay, so you have to pay the amount based on the hours basis you utilize. The cheapest option. So this is the very cheapest option, but the workloads can be interrupted. So you can use this, might be for a batch processing, just like a cron jobs running for uncertain times, or some applications, scheduled applications running, something like that. So these are the more useful batch processing jobs can be done using this spot instances model. So next one is then a dedicated host. This is the pricing options. Provide users with physical servers that are dedicated to their use, providing full control over the underlying infrastructure and compliance requirements. So these are the dedicated host. Host means the physical servers, they give you full control to you. So what you can do with the physical access. So this is example, say that if you have a law requirement or the data storage requirements or regulatory requirements, then this dedicated host can be purchased on demand or on a reserved instance, with pricing based on the size of the instance and the terms of the commitment. So it might be based on demand or reserved. So reserved would be more easy for dedicated host, like reserve this host for 1 or 3 years. So the pricing model would save you more cost, right? And this would be a more dedicated instance or the dedicated host for you. You can use whatever you want. When you can use, what is the use case here? So to deal with the corporate compliance requirement and around the tenancy model. So if you have any compliance or the regulatory requirement, so the data should be not shared with any of the shared hosting, something like that. So it should be a dedicated host for you. Best option for hardware based licensing models. Example, say that you purchase some MS SQL license based on the hardware, or some VMware license based on your hardware models. So that is a good example for to use this dedicated host. No multi-tenancy, server is not shared with any other customers. So this is a compliance requirement that the server is not shared. It's a dedicated host for you. Dedicated host means it's a physical server dedicated to you. So that's the dedicated host model. Dedicated instances. Dedicated instances, in the sense, this is an instance that's run on hardware that is dedicated to their use, but without the full control and visibility on dedicated host, because the backend dedicated host might be shared, but the instance is dedicated to you. Dedicated instances are priced the same on demand instances, but provide additional isolation and compliance benefits. So here it is just like the on demand instance what you run, but it provides more isolation and compliance benefits. That is the dedicated instance here. So some of them here, you have the saving plan. So how you can save the cost whenever you're running anything on AWS, the EC2 instances, right? AWS Saving Plan is pricing option that allows users to save up to 72% on their AWS compute usage in exchange for making a commitment to use a specific amount of compute usage. So this is actually a commitment for 1 or 3 years. You say that, okay, this is the instance I use for 3 years. So okay, so this is measured in dollars per an hour, right? So that's how it is mentioned. So if you give then a contract terms, like say I need this instance for 3 years, so you committed to that, so you will get a more savings. So there are 2 types of saving plans. One is a compute saving plans. These are best suited for users with steady state or predicted workloads and provide the most flexibility in terms of the instance families and operating system that can be used. Compute savings plans offer up to 66% discount compared to on-demand pricing with no upfront cost or minimum usage requirements. So that is a compute saving plans. So EC2 instance saving plans, these are the best suited for the users with steady state workloads that are using a specific instance family, size and region. EC2 instance saving plans offers up to a 72% discount compared to on-demand pricing with the requirement to commit to a specific instance family, size and region. So this is just a name. 72% you save if you compare to the on-demand, what you use on-demand, but this should be in a specific instance family, right? So what instance family you use based on your requirement. You need more CPU compute, or you need more memory, or you might need more storage based on your requirement, and what is the size of it, and what is the region you select. So based on the region, the compute cost varies. On one advantage of saving plans is that they provide greater flexibility than reserved instances. So this is the more flexibility. So when the saving plans, for example, you wanted to cut it, you can cut it whenever you need, allowing users to easily switch between instance families, sizes and operating systems without having to modify their commitment. So this is the one major advantages if you take in a savings plan. Additionally, so you can save plans or automatically apply to the most cost effective usage, provide users ongoing cost optimization without any additional effort. So this is a savings plans what you have on the EC2 models. So let's see what EC2 can provide. So EC2 can provide more something like elastic load balancing. So elastic load balancing is automatically distributed your incoming application traffic across the multiple EC2 instances. So this is a load balancing mechanism where the traffic will be load balanced in between the EC2 instances, right? How you set up it. So there are some EC2 load balancing models here. So one is an application load balancer. This load balancer is designed to distribute traffic at the application layer. So this is on a layer 7 model, routing requests based on the content, URL or HTTP header values. So where you can filter the HTTP header values and you can write the rules. LB supports advanced routing features such as path based routing, host based routing and support for web sockets. So this is one type of load balancer where you can use application load balancer. This is best use case for the applications to balance your user traffic, right, based on the path based or host based or web sockets, right. Network load balancers. This load balancer operates at the transport layer, so it's on a layer 4, forwarding traffic to a specific IP address and port. NLP is designed for high throughput, low latency workloads such as for TCP and UDP traffic. So this is basically high throughput and low latency. Example, your loads, example say that the database transactions you're doing, right? So this is a more throughput and low latency. The database response should be low latency workloads. So that's where you can write. Or the applications might require more IO to draw, so that's where you can use this network load balancing, or maybe load balancing stuff between the network layer as well can be a good fit for this. Classic load balancer, this is an original load balancer provided by AWS. This is the first one, supporting both layer 4 and layer 7 routing. So most of the times they use classic load balancer if they don't have any particular use case, right? And there is one more called gateway load balancer, can be used to manage traffic to and from internet facing resources such as web servers and other services running on EC2 instances, and can be configured to work with AWS Transit Gateway to provide centralized hub for connecting multiple VPCs and on-premises network. So this is basically a route where you can take your internet facing resources, right? Where it might be some web application hosted over there, or maybe some instances which are set for accessing remotely. So that's where you can use this GLB. So what other services the Elastic Compute can provide us? So this is an Elastic Autoscaling. This is very good feature we can use on EC2. EC2 Autoscaling is an AWS service that allows users to automatically scale their EC2 instances based on demand, ensuring that applications can handle traffic spikes and changes in workload. So when example say that you some seasonal, you have some plans, right? Maybe you have some festival or Christmas or New Year, then you put some e-commerce website there, you put some offers, right? That time more users coming, then what you can do is that you can configure this auto scaling feature, which will automatically bring up your auto scaling, and will add more instances when there is a more workload. If there is no workload, then it automatically removes those instances, right? So that is just like expanding and syncing, just like a rubber band, elastic rubber band. So that's how the elastic auto scaling works. With EC2 auto scaling, users can define scaling policies that controls how and when additional instances are launched or terminated based on criteria such as CPU utilization, network traffic, or other custom metrics. So based on the metrics, you can just launch the instances or you can terminate the instances. So those are more flexible scaling options. So this scaling can be done vertical scaling, like you add more resource to the existing instance, just like more CPU cores, more memory, or higher network bandwidth. So that's one. So you have one instance, you're adding more resource to the same instance, that is called a vertical scaling. Horizontal scaling, like you have a one server adding parallel servers to the same resource group, that is called a horizontal scaling. So example, you have instance 1, you add instance 2, so you have 2 instances, you add one more instance, they become 3, you add one more instance, they become 4. So that's called a horizontal scaling. So this is how the Elastic Compute and their compute models and their pricing models and those services are on EC2. So that's all about this session. Thanks for watching. Stay tuned. Please subscribe to the channel for more upcoming videos and courses.